everybody. I thought I'd show you the something of information about the Moon Lab. Okay, so here's the Moon Lab manual. And remember, we talked about how this is going to be an all semester project. And this is actually used in both Astronomy 101 and 103. So I will put that in there. Oops, 103. There we go. All right, so the idea here is that you need to, for this lab, you need to get out and observe the moon. There's several things that you're going to be doing. And I mentioned to you on the Moodle page, this is something you need to start now because you need to observe all the phases of the moon. And it could be that you're going to get clouded out the first time, say, you try to observe a full moon, and you're going to need to get out there and try again, okay, and to be able to fill everything out. So don't miss your opportunity. I want to see an entry for every day, so I'll talk about that in a second. Let's just scroll down in this lab. Okay, so there's a couple different activities, and the first one is to look at the moon illusion. Now you might have seen this when you're driving along the road and you see this giant moon near the horizon. Now that happens only when the moon's near the horizon and it looks so big, right? So this is your opportunity to really look for that and to do these little activities that come with it to help to understand that illusion. Okay, I won't say any more about that because you're going to figure that out yourself. All right, and then the next activity is all about observing the phases of the moon and observing the direction to the moon. Okay, now this is where you're really going to have to try to go out every night. And you're also going to be keeping a log. I'm going to scroll down and scroll back up. And you can see here there's a log that I want you to keep on a separate piece of paper in a notebook somewhere. You're going to take a picture of that and upload that with your lab when you're all done with this lab. This lab is due at the end of the semester, so you have all the semester to do this, or session if this is a summer class. So you need to really get out there. But every day I want to see a log entry into your notebook. So for instance, here's some examples: 8:24 p.m. Lynchburg, right? We want date, time, location, Lynchburg, VA, and then some notes like moon viewed close to the first quarter phase, phase noted in lab manual. That's perfectly good. Then the next day, 8:25, 10 p.m. Lynchburg, VA, tried to go out and look at the moon, raining and cloudy, view, oh, it should say unsuccessful, not successful. Let's put that in there, right? View unsuccessful, could not see the moon. So you need to every day have a log about what you saw when you went out, or maybe you couldn't go out because it was raining, whatever it was. Or there might be some personal circumstances that prevented you from going out, but you should note that. You don't have to tell me exactly what they were, but you can note that you could not go out that day. Okay. All right, so let's scroll back up. But if you are successful and you see a particular, for a whole month, I want to see the phase, right, drawn in. You draw the phase in here, just color it in, right? So color in the dark part of the phase, put in the date and the time that you observe this. So every time you actually make an observation, you color that in, okay? Now these don't have to be in sequence, like day after day after day, but it's kind of nice if they are. So it's nice to make a copy of this, fill it in as you go, and then when you're gonna hand it in, recolor it in sequence of date. You know what I'm saying, I hope. Okay. Or in sequence of how the phases go, right? One after the other, right? Like, okay. So going towards full and then going towards the new moon, right? So try to fill that out in sequence. It's nicer to look at. All right, and then the other thing you need to do is fill in this table here. If you see this table, it's just the observation number from above. So when you're done with all that, well, so every day you better keep note of the direction you're looking, right? So I didn't put that in the log, but you should keep track of that, because once you fill that in up here, you also need to tell me the direction to the moon, okay? And we're going to see a video that will help you figure out how to orient yourself in the, to the night sky. Okay. So let's see. And then the last thing is just an observation. This is kind of fun. Observation of the supposed, pictures in the moon. There's lots of things that people see in the moon. Of course, you could make up your own. but there's these typical ones like the rabbit and the face and the the woman. Yeah, so it's nice to observe those and make comments, and that's the last part. Now remember, you also have that log every day, right? Okay, and in the end, you're going to take this all filled out and your log all filled out and make a whole PDF of the whole thing, and then upload it to Moodle. Okay. So let me show you a few things that can be helpful for this project. So one is, there are lots of moon phase calendars so you can predict what the phase is going to be. I like this date and time one here. You can see the address up here. Now, if you just put in search for date and time moon calendar or moon phase calendar or moonrise, any of these things here, you can see it'll come up and ask you for your city, right? So I put in Lynchburg already, but you of course put in your own city. All right. And it tells you all the different, for the whole month, all the different phases. And you can see here, here's the full moon, right? Here's the third quarter. If you hover over it, it'll tell you the phase. Now, it doesn't have all of them here, right? It doesn't have the pictures, but you can see like where it would be. So third quarter, new moon, right? First quarter, etc. Now, when you click on an individual phase like this, you see this cool diagram, which tells you when it's going to rise. So the rise is at this particular phase, right? And is going to be at 12:05 a.m. Okay, so it's in the middle of the night. And then it's going to set over here at 1:53 p.m. So it's at its highest point up here. That's what this little graph is showing you. Its highest point here in sort of the middle of the day, 7 8. Well, sorry, not middle of the day, middle of the morning, 7 a.m. So it's kind of hard to observe, but to get up there, because probably you want to observe it when it's at highest up. It's just easier to get to. But you can use this app to see when things are going to be up and what the phases are. So you can see today is August 25th, 2020. So, you can see exactly what the phase is of the moon. All right, so I like these. There's also this moon phase calendar, which is really cute. This is from Moon Giant. So it shows you the whole month, right? So that's kind of neat. And there's also this lunar phases simulator, which is from the university astro.unl.edu. And if you go to that and look for animations, there's many, many different ones. This one is called the Lunar Phase Simulator, and it's got a little animation that shows you where the sun and moon are. So notice in this case, the sun and the moon are rising almost at the same time, right? So it's kind of neat. Also will help you understand the moon phases. Okay. Anyway, there's lots of cool tools to use. All right. And now let's look at a video about the sort of directions and coordinates in the sky. This is a great series called Keep Your Eyes on the Sky. So there's a lot of great stuff here for observers, and we'll probably look at a few of these as we go through the course.
Hi, I'm David Fuller from the Eyes on the Sky video series. Let's look at stargazing basics, starting with understanding directions in the sky. Most of us are already familiar with the cardinal directions of north, south, east, and west. These can be further split into 16 subdirections like southwest or south-southwest and south-southeast. But all that really tells us is what direction we are looking from our location, and at best, really only in areas close to the horizon. Not only that, just as the sun rises in the east and sets in the west, the stars in the night sky also rise in the east and set in the west over the course of a night. So how do we discuss other aspects of the sky? Well, let's start with those cardinal directions again. If we split the sky exactly in half, from north to south, we would have a line bisecting those halves. That line is called the meridian. This line never moves because it always divides the sky from north to south. Now, if we locate the exact halfway point of the meridian, we're looking directly overhead, and that point in the sky is known as the zenith. So what other locating features in the sky are there? Although we don't see stars during daytime, the imaginary line in the sky that the sun traces as Earth revolves around the sun is called the ecliptic. Since the planets in our solar system orbit our star largely on the same plane as each other, kind of like a giant pizza with the sun in the middle, the path of the moon and planets in the sky closely follows this line of the sun. This imaginary line appears lower in the sky during the summer and higher during the winter months at night. So close to, or sometimes right on, the ecliptic is where we will always find the naked eye and telescopic planets in our solar system and the moon. Now keep in mind that the sun doesn't actually rise or set. What's actually happening is the Earth is rotating. We just don't feel that rotation because we humans are just along for the ride. So as Earth spins, imagine if you were standing at the North Pole and looked straight overhead when it was dark. The stars would appear to spin around a circle, and the axis of that circle at the zenith, the point overhead we talked about earlier. That point in the sky around which the stars rotate is the celestial pole. Of course, you likely won't ever see that because no one lives at the North Pole. So as we move downwards in latitude in the northern hemisphere, that point in the sky around which the stars rotate will move down towards the north part of the horizon. If you're in the upper latitudes, it will appear higher in the sky. The nearer you are to the equator, the closer that point is going to be to the northern horizon. If you've ever looked at a globe with latitude and longitude lines on it, you can probably imagine pretty easily our next set of markings in the sky, the celestial sphere. To locate objects in the sky, we use coordinates like on Earth, but instead of latitude and longitude, we project those lines out into space as if they were on a transparent sphere surrounding Earth. And these are called right ascension and declination. Right ascension is actually easy to remember. If you face north and the sun rises in the east, which side of your body is that on? Well, it's on the right side. So the sun ascends from your right, or right ascension. These are like the longitude lines on Earth that start at one pole and run to the other pole in equal spacings. Now in right ascension, they're listed in hours and minutes, and the 0 hour for right ascension begins in Aries the Ram, which is a zodiac constellation. Easy enough, right? And declination is simply the number of degrees away from the celestial poles. So the degrees from the celestial pole to the celestial equator is 90 degrees, the equator itself being 0, just like the degrees from our North Pole to our equator on Earth. With me so far? Great. So let's review these quickly. North, east, southwest never change, of course. The meridian splits the sky in two halves from north to south. The zenith is directly overhead. The ecliptic is the path the sun takes in the sky, along which the planets largely appear to follow. The celestial pole is the spot in the sky around which the stars appear to rotate as the Earth spins. The celestial sphere uses similar coordinates as longitude and latitude, but are called right ascension and declination. Not hard at all, right? Okay, right ascension and declination may take a bit getting used to, but the rest should be pretty straightforward. In the next video, I'll explain how to understand the difference between brightness of objects in the sky. Thanks for watching. I'm David Fuller. Keep your eyes on the sky and your outdoor lights aimed down by using dark sky-friendly lighting fixtures so we can all see what's up.
So it's a great video series. I encourage you to watch more. Like I said, we'll probably watch more as we go through.